So, before we get to the main topic, I'd like to touch on a small subject. As always, we will go over the main points, the essential aspects, and just briefly skim the surface. To put it simply, or if you prefer to use more complex terminology, let's give an example from real life. Let's say in real life, we have objects that each possess their own unique properties. For example, if we're talking about skin or wax, we know that the light that hits the skin scatters inside it. There are objects like fabric where the light scatters not inside but on the surface. There are objects that absorb a lot of light, like black objects, which are mostly black in color. And all this information is also necessary for Unreal, so that it can display it correctly for us. PBR stands for physically based rendering. This is a method where Unreal Engine, according to the laws of physics, our real-world physical laws, tries to render things as accurately as possible. For us, when we tell it to render, for example, a metal object, let's make it metallic, it asks us for additional information, such as whether there will be visible scratches, dents, or other imperfections present. How glossy is this object? In other words, is there any roughness, and so on. In short, it asks us for extra information about the object. The PBR concept is actually used not only in Unreal or other engines, but in programs in general when creating materials. Let's take this material for example to make it easier for us to understand. When we create a material, we need to connect certain data, some information. We need to connect this information to the material so that the material processes it, and depending on what you connect, it gives us the result. So, in most software, PBR, which stands for physically based rendering, is generally based on four different types of information, with the first being the base color. If I switch the scene to an unlit mode, you can see that this metal is white, or rather, much closer to white than any other color. Right now, because our stage is quite dark, we can't really see it very well. But if I light it, add some brightness, for example, to the sun, then you will see that it now appears more like gray, like its own true color. These are the properties of metal. Okay, next is whether the object is metallic or non-metallic. Basically, it is more correct to say that either an object is metallic or non-metallic because intermediate values can be used. Of course, we can use the panels to place values and correctly determine whether it is metal or not metal. Next, we have roughness, which describes whether the object is glossy, shiny, or rough in texture, and the latter is generally the norm. But in simple terms, to put it roughly, these are irregularities, some kind of information about where there are bumps, raised areas, and where there are depressions or dips. That's all, meaning all this information is actually needed by Unreal so that it can properly display the material for us in a physically correct way. All right, then we have some additional information. The more realistic and detailed we want the object to look, the more additional information we can connect. Basically, if you try to assemble a material for some object, you might see various textures, such as bumps or grooves, ambient occlusion, sometimes specular. Possibly, if there are some elements of translucency, then the following channels as well. So, this is additional information that Unreal needs to effectively convey the overall appearance of the object or material in a more detailed and believable way. Now, the last thing I wanted to mention, the area of application that we talked about in the previous lesson. The only place where PR is used is either in surface decals, because it makes sense to say that light is not an object, it's light itself. It does not require information or Bayeri information in order to function properly and correctly. This is a completely different concept, and for volumetric effects, it's also different. They don't need this information either. As for PR, I won't even mention it. It's a separate process and a fake interface. The only reason this information is needed is to physically accurately display the object, which is what this geometry represents. And geometry is handled by the G buffer. We've talked about this as well. The geometry buffer collects information about the geometry, its color, and passes this information further along. Alright, initially we have objects, and they each have their own colors. This information, that is the object's data, is partially passed on to the decals. In other words, decals make small changes, minor adjustments, and then passes this information further along. So it's simple, either the surface or the decal layer. They use this information. Basically, all the objects we load in here, anything we place, walls, any items, whatever it is, when we apply a material, that's what becomes the wall object, meaning the surface. That's probably about 60 to 70% of all objects, all materials. Yes, that's really what it is, essentially. Ooh, that's probably all there is to say on this topic.